Hello friends, today we are going to do with the chapter trigonometry, and we are going to do with introduction to trigonometry and one problem based on it. I have said in the previous video that we will be doing on the problems based on arcs of circles, but I have seen the models and the problems of arcs and revision problems which are similar to those of the problems which I discussed in the problems of arcs and circles in the previous video. Okay, so I'm not going to do the revision problems as those are similar to those of the problems which I have done in the previous video. So I'm going with the chapter trigonometry. So before going into the video, I would request you to please subscribe to my channel and like the video and share it to your friends. Okay, now here trigonometry is nothing but measurement of angles, triangles. Okay, and we are going to do with trigonometrical ratios in this particular chapter. Trigonometrical ratios means the ratio between the lengths of a pair of two sides of a right angle triangle. Okay, that is trigonometrical ratio. So before going into that, we have to know what is a right angle triangle and where can we apply this trigonometry ratios. It can be applicable only in a right angle triangle, and right angle triangle means you all know that any one angle should be 90 degree in a triangle, then the triangle is said to be right angle triangle. Here you can see angle B is equal to 90 degree, so this triangle is called right angle triangle. Okay, now here we are having particular ratios. Here you can see sin A, cos, tan, cot, secant and cosecant. So before going to that, we'll be just doing these all in a right angle triangle and then we'll proceed on to further. Okay, now here let us take a right angle triangle. This is hypotenuse. Hypotenuse is nothing but the angle opposite to that of the 90 degree. The side here AC is hypotenuse. Okay, because it is opposite to angle B, that is 90 degree. Now here we are having sin A is equal to perpendicular by hypotenuse. Just ignore this. This we are not having because I took the triangle differently. Okay, now here perpendicular by hypotenuse. First we should know what is a perpendicular. Trigonometry cannot work on this 90 degree. It will work on either of these two angles, angle A or angle C. Let us take this angle A. So perpendicular of angle A is equal to BC. Okay, perpendicular is nothing but the opposite side. You can say the perpendicular is nothing but the opposite side of that particular angle. So if you can take angle C, this perpendicular opposite side is AB. This one angle C opposite side is AB, so it will be perpendicular of angle C. Okay, and next we'll be getting base, a term called base. Base of angle A is nothing but AB. You can also call this as adjacent, and adjacent means you cannot take it as the hypotenuse. Adjacent, here the angle is there, right? This angle where it is lying, on which line it is lying, which is not the hypotenuse, is called as the base. Okay, so here we can remove perpendicular and base, this perpendicular and base. Instead of that we can write perpendicular as opposite. Okay, opposite, and base as I can write adjacent. Okay, now to remember all these formulas we are having some tricks. Okay, first let us take sine, cos, tan. Sine let us take first. Sine is nothing but perpendicular by hypotenuse. So what is perpendicular? Opposite by hypotenuse. Okay, and cos is nothing but base by hypotenuse, which is adjacent by hypotenuse. Adjacent by hypotenuse. And you can take the tan as perpendicular by base, so you are getting it. Perpendicular is nothing but opposite, so opposite by adjacent. Base we took as adjacent, so let us take tan as opposite by the base we took as adjacent. Let us take. For this one we can remember like this. Okay, this one you can see over here, this one. So now you can remember it as SOHCAHTOA is nothing but here S is sine and opposite by hypotenuse, cos adjacent by hypotenuse, tan opposite by adjacent. Like that it is easy for you to remember. For that I am giving. Now you can think, what about the other trigonometrical ratios? Cotangent, secant and cosecant. So this is cotangent. This is actually sine. Sine it is SINE, sine, and this one cos is cosine, and tan is tangent, and this is cotangent, and this is secant, and this is cosecant. Okay, I hope you got. And for this all, in order to pronounce it, this the big letters, they have represented it with the small letters like secant, SEC, cot, cosec, like that. Okay, now here we can see, first let us take cot. This is cotangent. Where did we find tangent? Yeah, here in tan we are finding. What is actually tan? Perpendicular by base or opposite by adjacent. Here you can see base by perpendicular. Just the reverse of tan is the cotangent. And you can see secant. Secant is hypotenuse by base. Once refer cos, base by hypotenuse, and secant is just the opposite of cos. And here cosec is just the opposite of sine, perpendicular by hypotenuse, hypotenuse by perpendicular. So like that you can remember easily. Only we are taking opposite, perpendicular as opposite and base as adjacent, and we'll be doing like this only the all problems we are going to do with. Okay, and in this chapter we also need to know about the Pythagoras theorem. I hope you know it. In a right angle triangle, okay, let us take this triangle as ABC. Suppose AB let us take as 3 centimeter, BC 4 centimeter, and if we want to find AC, what is a value of AC, we can find easily by applying Pythagoras theorem. Pythagoras theorem is nothing but hypotenuse square. Hypotenuse means the side which is opposite to the 90-degree angle. So AC is opposite to 90-degree angle. So AC square will be equal to the sum of AB square and BC square. Means the hypotenuse square will be equal to the sum of the individual squares of the sides of the triangle. Okay. So what does this sentence mean is AC square is equal to AB square plus BC square. So here AC square we are getting AB square nothing but 3 square plus 4 square. Okay. 3 square plus 4 square. AC square is equal to 3 square is nothing but 9 and the 4 square is nothing but 16. 16 plus 9 is equal to 25. So when we square root on both sides, we are getting AC here square and root cancel. AC is equal to root of 25 is nothing but 5 centimeter. So now here AC is equal to 5 centimeter. This is what the meaning of the Pythagoras theorem. It will be applicable in this chapter very much, and we have to know both the trigonometrical ratios as well as this Pythagoras theorem. Okay, and we are having some reciprocal values. You can see reciprocal values means you take sine by cos. Okay, sine by cos, let it be any angle, let the angle be theta. Okay, you can represent an angle with so many Greek letters. So these all are Greek letters, the theta, phi, alpha, beta, gamma, these all are the Greek letters. Mainly we are using theta and phi. These will be using much, so these are enough to represent the angles. So sin theta plus by cos theta, you can write it as tan theta. Okay, tangent is equal to tan theta. These all are formulas. You just have to remember this. Once we are thorough with these formulas, we can proceed with the problems of trigonometry. Sin theta by cos theta is equal to tan theta. Same way, when you reciprocate it, cos theta by sin theta, you are getting is cot theta. Okay, you know 1 by tangent is equal to cotangent. When tangent is reciprocated, tangent is reciprocated is nothing but it is divided by 1, means 1 is divided by it, 1 is divided by it, 1 by perpendicular by base, 1 by perpendicular by base. This is what the statement actually meant. Okay, and 1 by perpendicular by base is nothing but base by perpendicular, which is the result of cotangent. And all cosec is also same as sine, and secant is also same as the cosine. Okay, now hope you are thorough with it, and we'll be doing a small problem now, and we'll be doing only this problem. In the next video we'll be doing more problems on trigonometry to hold a grip on it, and in the meanwhile you have to remember the formulas very thoroughly. You can remember this one as I have suggested. You can remember perpendicular base we have modified into opposite by adjacent, like that. Okay, now here a figure is given. Let us take like this. A triangle is drawn over here like this. Now here this is 90 degree. This is triangle A, B, C, and this is 13. This is 5. This is not the centimeter. You cannot take it as centimeter. Never you can take it as like that. you have to take a ratio constant for that. Then whatever we are getting the value with the ratio constant, that we have to write there. So I'll be telling you now. Now from the figure, first we have to find sine A. Okay, this one here, this angle sine A. Okay, we have to find it. Now here in this triangle, this is 90 degree, and here it is given 5 and this is 13. The opposite of 90 degree is the hypotenuse. So what will be by Pythagoras theorem? The statement will be the equation. The equation will be AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square plus BC square. Okay. Now here AC square is nothing but 13 square. 13 square is equal to AB square. AB square is 5 square and BC square is not given. Okay. Now we have to find BC. BC square is given, and BC square, if we leave that side, leave this side, and 5 square will be moving on to LHS, and 13 square minus 5 square. What is 13 square minus 5 square is 169 minus 25. So BC square is equal to 169 minus 25 is nothing but 144. So square root on both sides, we are getting BC is equal to 12 centimeter. Okay. So now here this is the actual way we do, but we have to take a ratio constant, because here you can see, here in the question it is not given as centimeter, meter, kilometer, nothing is given. Just they gave 13, here 5. There is no numerical value. So you can remember that each trigonometrical ratio is a real number and not a unit. Each trigonometrical ratio is a real number and not a unit. So it is not having any unit. So then you can understand it as trigonometrical ratio. Then what we are going to do here is, instead of 13 square, we will write x square also. Okay. And instead of 5 square, we will be writing 5 square x square. Means 25 x square we are getting. Here 169 x square we are getting. Here we are writing 169 x square minus 25 x square, which gives the result of 144 x square. So this is nothing but x. What is 144 x square? Root over 144 into root over x square. Here root and square cancel. So here 144 root is nothing but 12, and here x square root is nothing but x. So we are getting the 12x, and while writing this 12x on the diagram, you should not mention the x. You should just write 12. Okay. That we have to do for every problem unless and until it is given a unit. Now first they asked to find us sine A. Sine A we can remember here opposite by hypotenuse. Sine A is opposite by hypotenuse. So is equal to the angle, the side opposite is 12 and hypotenuse is nothing but 13. So it will be 12x by 13x. While writing, you have to write it as 12x and 13x, and here you will be cancelling x and x, which in results give you 12 by 13. This is the procedure which you have to do in your exam. You cannot directly write it as 12 by 13. You have to take a ratio constant unless it is given a unit. And second, they asked us to find cos C. Cos of C. C is nothing but this angle. Okay? Yeah. Now cos C let us find is equal to, so cos is nothing but adjacent by hypotenuse. What is this adjacent? You should take it as 12 and not 13, because 13 is the hypotenuse. It cannot be represented as the opposite nor adjacent. It is only the hypotenuse. For this one, this will be hypotenuse, and for this one, this will be opposite. Sorry, for angle A, this will be adjacent, and for angle C, it will be opposite. These two sides can be opposite as well as adjacent, but hypotenuse can never be like that. It is only a hypotenuse. Okay. Now cos C. Cos C is nothing but adjacent by hypotenuse. Nothing but 12x by 13x. Same as the before one. 12x by 13x is equal to 12 by 13. Okay. And next, they asked us to find tan A. What is tan A? Opposite by adjacent. So nothing but 12x by 5x. Okay, is equal to 12x by 5x. It will be possible to solve this fast once we are thorough with the formulas. Is equal to 12 by 5. Okay, and next is we are having is cosecant C. Cosecant of C. What is cosecant? It is actually the result of the reversing of sine. Sine is opposite by hypotenuse. So cosecant will be hypotenuse by opposite. So this is hypotenuse and this will be opposite. So cosecant C is equal to hypotenuse by opposite, which is equal to 13x by 5x, which is in result is giving us 13 by 5. And next, they asked us to find secant square A minus tan square A. Okay, this is a bit complicated. Secant square A, first secant A will be finding. Okay, what is secant? Actually the result of reversing of cosine. So cosine is nothing but adjacent by adjacent by hypotenuse, and secant will be hypotenuse by adjacent. So it is of angle A. So hypotenuse is 13 and this is 5. Adjacent is 5. So 13 by 5 whole square. Here 13x by 5x whole square. Here x and x cancels. Minus tan square A. Tan square A, tan A we have already found that it is 12 by 5. Okay, tan we have already found that it is 12 by 5. You can also check it again of angle A. Tan is opposite by adjacent, 12 by 5 or 12x by 5x whole square. 12x by 5x whole square. So here again x and x gets cancelled. Okay, now here we are getting 13 square, that is nothing but 169 by 5 square is 25 minus 12 square 144 by 5 square 25 is equal to, by 25 LCM is nothing but 25 and 169 minus 144 169 minus 144 is nothing but 25. So 25 by 25 is resulting in 1. The final answer is 1. Okay, this is the answer. So like this, complicated problems will be there, and it will be possible once you know the formula very thoroughly and very easy to remember. I have said the following, that is sine is opposite by hypotenuse, that one you can, if you want you can follow, or otherwise the formula which I have showed, that also you can follow. That's up to you, and we have to be thorough with the formulas. So thank you all for watching my video, friends. In the next video we'll be doing more complicated problems based on trigonometry and trigonometrical ratios. And thank you all for watching my video. Do like, share, comment and subscribe to my channel. Thank you for watching, friends. Thank you.